In this problem, we're given an inequality. It's, again, a nonlinear one. And this time it happens to involve a fraction. Now, some of you might be tempted, oh, I have a fraction, so I should multiply by my common denominator. It's just one problem with that. We don't know whether x is positive or negative. So we don't know whether x minus 5 is positive or negative. So if I multiply by x minus 5, I don't know whether I should flip the direction of the inequality or not. So that's where that idea kind of falls apart. Instead, that's not going to work. We need to get it greater than or less than 0. So we begin by bringing the 4 over to the other side. Now, as I do that here, you can see I've already written it. I need a common denominator here. So that gives me the x minus 5 in the bottom. But I also have to put an x minus 5 at the top. And then that way we can put these two fractions together. So I get the common denominator, I bring the 4 over, and that's x minus 5. And then once I have my two fractions here, I can go ahead and put them together. So at the top I'll have 8 minus 4 times x will be minus 4x. And then the minus also distributes times 5, makes that plus 20. And that'll all be over x minus 5. And then we continue here, simplifying across the top, combine like terms. 8 and 20 would be 28, minus 4x, all over x minus 5. And now that's less than 0. And so now that we've gotten the equation in the form where it's greater than or less than 0, we can set about finding those key values where it could change sign. And those would be values that make function 0, which would make the numerator 0, or values that make it undefined, those are vertical asymptotes and holes, things that make the denominator 0. And so we solve numerator equal to 0. That would give me 28 minus 4x equals 0. We can bring the 4x over, divide by 4, and we get one of our key values is x equals 0. And then likewise, we find out when is the denominator 0. Well, when is x minus 5 0? Bring 5 over, we get x equals 5. And so we have two values of interest here. One that makes the numerator 0, so it would make the whole thing 0. One that makes the denominator 0, which would make it undefined. Okay. And now we go and solve the inequality. So we plot those values on a number line. Now, because the inequality is less than without the bar, they're automatically not going to be included. If this had been less than or equal to with the bar, then we would have included the 7 because that made the numerator 0, and therefore the whole thing 0. Even if this was less than or equal to, we would not have included the 5 because the 5 makes it undefined. Okay. And then we just need to test the value in each region. Something smaller than 5, something between 5 and 7, something bigger than 7. So here I might do 0. Whenever I can pick that, it's always a good one to pick. Here 6 is probably the easiest thing to do. And maybe we'll say 8. Okay, and then we start to work this out. We plug 0 in to our fraction right here. That'll be 28 minus 0 over 0 minus 5. It'll just be 28 over negative 5. So negative 28 fifths. And so therefore that region is negative. We plug in 6. Turns out you actually get 4. Just a positive 4 when you work all that out. And so that's positive in that region. And then we plug in 8. And when we do, we'll get negative 1.3 repeating, or negative 4/3. And so it's negative in that region as well. And then we go back to the inequality and say we want less than. So in other words, we want all the regions where it's negative. And so we would write that out as the interval from negative infinity to 5. union the interval from 7 to infinity.